Good morning, good afternoon, good evening, ladies and gentlemen. Welcome back. Another live broadcast of the Kev Baker Show for all of you that are tuned in today on Truth Frequency Radio, www.tfrlive.com. You may be listening on iHeartRadio, TuneIn Radio, either of those apps. A big shout out to all of you out there. And we're also going out live on the Kev Baker Show YouTube channel. So a big shout out to everyone out there, wherever you are, whenever you are. I've got an absolutely brilliant show lined up today. I'm super excited because it's our first time teaming up with our resident scientist. Yes, you all know I have really grown fond of one of our regular guests on here because myself, I'm a science geek. I love it. I'm learning all the time. And when I'm joined by today's guest, I myself, and I think a lot of you out there as well, we do grow because we're given such brilliant information to think about by my good friend, Brendan Drachler. Now, for anyone who doesn't know who Brendan is, he is our, I like to kind of cutely call him our resident astrophysicist on the Kev Baker Show. But he is actually, in real life, he is an astrophysicist at the Rochester Institute of Technology. And he's currently working on how to understand how we can detect the most dense and energetic objects in the universe. That will be black holes and neutron stars. Now, on top of that, he's also working to understand the fundamental structure of black holes and how we can learn more about them. Brendan has spoken on topics ranging from the solar system to the nature of dark energy, to supernova, and many things in between. And off the top of my head, I can remember talking to Brendan about so many topics that are outside of his specified field of astrophysics, and that's what makes him one of my favourite shows of the month. Now, if you want to know more about Brendan, because he's not just working tirelessly at Rochester Institute of Technology, oh no. In fact, he, like me, has his very own podcast. And it's brilliant, folks. If you're into science and things like that, I can't think of anyone better to recommend than Brendan Drachler and his podcast called The State of the Universe. And you can find all of that over at thisstateoftheuniverse.com. It's available on Apple. It's most platforms out there. Our good friend Brendan, he's on it. And he's here with us live tonight. So Brendan, welcome back. First show of the year together, sir. How you doing, man?
I'm good, Kev. Thanks for having me. I appreciate it, man. It's been like 2 months.
I know.
It's been a long time.
Yeah, we had a bit of a hiatus there towards the end of the year. You were busy. I was busy, but we're back. We're good. How you been doing?
I'm fantastic, man. We're good. We just kicked off I took December off from the podcast, and I did it so I could upgrade everything on my end. New computer, new recording software, new everything. So we could kick off, schedule some guests, set everything up. And it worked out great because December was the best month in the podcast history in terms of numbers. And I don't understand why. It's weird.
What guests did you have on, man?
None in December. That's the thing.
You see, I find that as well. I used to think that I had to heavily rely on big name guests. But then when I do the solo shows, which I'm still not entirely comfortable with, I find that the audience really love that kind of personal one-on-one touch as well. So maybe that's what's really giving you the jump in numbers. I think you deserve a jump in numbers for the work you do anyway, brother. But did you have a nice Christmas? Did you have a very drunken New Year? I hope so.
Oh, for sure. Went to some New England Patriots games, screamed my skull off, got too drunk. It is what it is,
It really is. And Brendan, you send me so many topics ahead of our shows. Just to share with the audience, usually the onus would be on me, the podcaster, to come up with all of the ideas and interrogate the guest and try and get the information out of them. But Brendan, like Charlie Robinson, proves to be one of the easiest shows I could ever imagine. He sends me all the information he wants to get into, and all of it is the kind of stuff that has me on the edge of my seat. So I don't know where you want to start tonight, Brendan, but We've got stuff on the Tess
To
telescope.
see,
We've got the TicTac. We've got so much going on in the world, dude.
here's the thing, though. Like, it would be so nerve-wracking to me to not send you topics. Like, imagine if we didn't communicate at all before the episode and you just started bringing shit up. I wouldn't
Yeah.
know what to do. I
It's,
would, I would, you
some
know.
some some guests are like that. You don't hear from them from the minute you book them until the minute they turn up, and then you're kind of, it's a bit weird. And I think I can always tell the shows like that, the ones that are kind of very last minute. And like you say, the guests themselves, they've got no idea where I might be taking them, and that's why
Yes.
I think these shows that we do, they really are. They're amongst my favourite, and I don't just say that because you're here. I say it on other streams as well, man. So what do you want to get into first tonight, Brendan?
We can just jump into the TicTac, man.
The TicTac? You
I
want to
saw
get into
this.
the TicTac?
Yeah, every morning I wake up, I go on, the sort of popular science media and try to figure out what people are interested, what people are looking at, what new stories are going on. That's a really good way to just sort of get interested in the science. And then if I'm interested in something, I'll take a deeper dive. This was all over everywhere. There was a Freedom of Information Act request. I don't know if you saw this. I don't know if you saw this before I sent it to you. I assume you did.
I try to keep an eye on what the To the Stars Academy are up to, because
Yeah.
I don't trust them as far as I could throw them. I really don't. But that's another story altogether. But tell me, what's happening with the
Yeah.
TicTac, dude?
So the Freedom of Information Act request got denied, and it provided some interesting information. So you know all about the TicTac. You know more than I do about the damn TicTac.
Yeah, back
okay.
in we had 2017 in December, we had the whole Luis Elizondo coming forward, a whistleblower per se from the Pentagon, and he was talking about this ATIP program, the Advanced Aviation or the Advanced Aerial Threat Identification Program. And then he went to the Stars Academy, hooked up with somebody called Tom DeLonge, used to be the frontman
Yep.
for Blink 182.
Great band.
And to the Stars Academy, when you read through their board of directors, it's really weird because they've got like national security advisors on the board that have worked on Capitol Hill. Most of their board are ex-CIA, ex-NSA, ex-law enforcement. It's really strange, really weird. And then you've got this thing with the Pentagon. One minute they admit that there was an ATIP program, and the next minute they're saying there was no such thing. One minute they admit that Luis Elizondo worked at the Pentagon, the next minute they deny he worked there. And of course, in amongst all of this, we've had these release of videos, one pertaining or one that they refer to as the TicTac. So yeah, I've been keeping up to date with most of what's going on with this. I loosely call it UFO Disclosure. But what do you think's going on with all of this, man?
I don't know. It's interesting because I don't remember the guy that's involved, the Navy pilot that was involved. I don't remember his name.
David Favre.
Okay, was that the guy that was on the Joe Rogan Experience?
Yeah, yes, it was, yes.
Okay, so he was on there, and I remember him saying that there was like a longer video that showed a lot more stuff that isn't released. Do you remember this?
Yep.
And a lot of people say this is kind of an interesting thing. And so now it's confirmed that there's a longer video because it's also confirmed that there's many documents labeled top secret or secret that they weren't allowed access to on this Freedom of Information Act, and a longer video. That's interesting. And the Office of Naval Intelligence. Okay, I have a quote here written down. They said, release of this information would cause exceptionally grave damage to the national security of the United States. Now, Kev, I can be a conspiracy guy, but it takes me a while to get into conspiracy mind. What do you initially think? Because I know you and your audience are always, you're always in the clouds, thinking of ways in which people are conspiring.
No, you see, in recent times, Brendan, now I used to be deep down the rabbit hole. I used to be so far down the rabbit hole, I didn't know which end was up, okay? But then over time, over the years, I started to realise that some of the things I held as very strong conspiracy theories, actually, when I looked at them with a more open mind and without any confirmation bias involved, I would find that maybe there was a more down-to-earth explanation. That's not to say that there aren't conspiracies out there, but from what you said to me there about the national security of the US, there's two ways of looking at it. Firstly, I would say that suggests that possibly we're looking at advanced technology, either ours or from a foreign government, or it could literally mean out in the clouds, extraterrestrials, that kind of thing.
Mm-hmm.
I tend to lean towards something more terrestrial.
That's what I'm saying. Okay, that's where I'm at. But it's such a weird video and scenario because it's one of the few that exist where like the people are credible, you know?
Very
Like
credible.
Credible people. You have a video that was leaked. I don't think the government has ever came out and said that's a fake video, right? I think that's pretty well accepted that that's an actual video taken from a Navy pilot's cabin.
Yep.
Right. So it's a weird one, man. It's a weird one. I don't understand it.
Do you think sometimes, Brendan, they actually enjoy, or it suits them that people like me tend to go alien first and everything else later? Because when people like me then start talking the alien line, it kind of takes the attention off any secret tech that the US or anyone else might be working on. And we serve as a perfect distraction, as a perfect cover for them to continue their black ops, whatever they're working on. And we can talk about aliens till the cows come home, because we're not really pointing or shining any light on their actual technology, what they're working on, if that makes sense. It's almost convenient. It's almost convenient that we. Yeah, it's almost convenient for them that we put out the woo-woo, because then it diverts people's attention from what might be new technology that they're working on.
No, you do see that sort of thing happening all over. Now do you notice that all right, there's a few things in politics today that are used to discredit things. One of them is Russia. You know,
Yep.
Hillary Clinton calling Tulsi Gabbard a Russian agent, that happened since we last talked.
Yep.
It's like a thing that they use to discredit people, and conspiracy theory has become the same thing. You know,
it's like a meme. It's like a big meme.
It's like the Jeffrey Epstein thing where they say, well, that's a conspiracy theory, but it's almost like it's almost not a conspiracy theory. It doesn't quite, because in my mind, I think conspiracy theory is like woo. You know, that's what I associate it with, and that's what everyone else associates it with, which is why it's effective to say that like it's effective to say that scenario is a conspiracy theory, because then it seems to add some little bit of discredit to it. But man, it's like that's a weird one. It's like a conspiracy theory not to believe in that one. And this TicTac video, man, I don't know. I honestly I don't even know what to make of it.
Well, I'm playing that on the screen as we talk. I mean, I don't really know what to make of it either. Now, do I believe there are UFOs, alien crafts out there? Of course I do. I would be silly after every show I've done in the past saying I don't believe that, and I truly do believe they are out there. Now, can I confirm that what we're seeing in these videos are the same thing as what I believe in? No, I can't. So, I don't know. I'm very confused when it comes to all of this, Brendan. Because the people involved, like you say, that they're very, very believable. They've got the right credentials. And I just worry that maybe we're being sold a story to divert us away from something else, if that makes sense.
For what benefit, though? That's the question.
I don't know. You see, that's the thing. I don't know. I have no idea.
Yeah. Can we take a step back, Kev? I'm curious about this. So did you say that you believe there's aliens, like alien craft have visited Earth?
Yeah, I do. I do believe in the past and probably still now. Yeah. Now, can I prove it? No, I can't. I can't prove it. However,
isn't that one of the? That's like an interesting belief that people probably call you crazy for.
Yeah.
Some people.
Yeah. Oh, yeah. Yeah.
But there's like literally, you could flip a coin on that one, because we just don't know.
Exactly. And I would say to anyone, and I've got no problem with anyone who says, no, it's bunk. There's nothing out there. Like I say, I don't know that my own theory's correct, so I can't say anyone else's is wrong either.
I will provide you some interesting insight. We've talked about this on the show before, but scientists are just as willing to believe in aliens too.
Big time.
I mean, they just are. Do you remember last year? It's 2018, actually. Do you remember Oumuamua? Do you know what I'm talking about?
Oh yes, the first interstellar object, that
Yes, and
cigar-shaped.
it was openly talked about in scientific journals. I mean, I read papers that studied this object where the conclusion of the paper listed aliens as a potential
I think it's a scientist
option.
called, is it Avi Loeb? And I think he's at Harvard. And I think he's one of the main proponents of the alien hypothesis when it comes to Oumuamua.
Yeah, I've even heard, this is an interesting one I've heard. I've heard that it could be literally like an asteroid sent to impact the Earth. I've heard that one talked about in scientific circles. Like, imagine if there was an alien civilization who wanted to wipe us out, but they didn't want to just come here and wipe us out. So instead they sent an interstellar object,
Yep, I've read these theories as well. I have, and after Oumuamua, we had our second interstellar visitor recently as well. I think that was confirmed. It was an amateur astronomer in Crimea that had actually tracked something, and I think it had been confirmed as our second interstellar visitor. I didn't see all the hype surrounding that one that surrounded Oumuamua, right?
No, why would there be? It's the second one. Who cares about the second one?
Exactly, and it wasn't mysteriously cigar shaped and all the rest of it. And
I mean, that's the weird thing about Amumu. That was the weird thing, is the shape. That shape is not like a natural shape that you would expect an asteroid to look like, or a rock floating in it. It just doesn't mimic something that would have been produced naturally. It doesn't mimic something that would have been produced through a collision. It's just a weird object.
And I mean, here's the thing as well, Brendan, because we get the artist's impression of what it looked like, and it was that long cigar-shaped kind of rock. But in the end of the day, you can correct me if I'm wrong here. I mean, that wasn't a photograph. It was an artist's impression of an object. So did it even look the way that most of us think it looked? Because we've all got that image in our mind that the artist put together in his illustration of it. So, I mean, is it as cylindrical as we thought? Is it as mysterious as they're making out? I don't know.
Now, I'm not an expert on Oumuamua, but my understanding is that we do have an image of it, in the sense that we have photos taken from telescopes that show light reflecting off of it. Now, do we understand what the surface looks like? Do we understand any features? No. We understand generally the areas of its surface that reflected light. So you could imagine that there's maybe a rock made of iron, black iron, that doesn't reflect light well, and then you just have a strip. I'm not saying this is the case, but I'm just saying you could imagine this, and you just have a strip of a different material, across its surface, almost like what happens on Ceres in the minor planet in the asteroid belt. If you know what I'm talking about, Ceres, it has that bright spot, periodic bright spot. You could imagine something like that on an asteroid, an interstellar asteroid, whatever you want to call it, the mysterious Oumuamua, and it would give you the illusion that maybe it's a cigar shape. I don't know. I don't know how well that shape is actually been confirmed. It's a good question, though.
Yeah, exactly. I mean, it's interesting anyway, because it is that first, or at least the first we've tracked, interstellar visitor, as they call it. I'm sure it wasn't literally the first. I'm sure there's been more, but we just haven't seen them, right?
Oh, yeah. There's probably been thousands, I would suppose. Yeah.
So let me put you on the spot, Brendan, as a scientist. And I've mentioned that I believe there could be alien craft out there. What say you? Do you think, with the potential for all these exoplanets that we'll get into later, and of course all the planets that maybe we don't recognize as being able to host life, maybe they do. Do you think there's craft out there?
I don't, in the sense that there's probably not. Even if we were super advanced to the point where we could design, spacecraft to go to different planets. I don't think we would do it as humans. At the very least we would send a robot, right? At the very least we would send a robot. But this might be naive, and it's just not me being a super genius who can see 3,000 years into the future. But I don't see a way to do space travel. I just don't see it. Not to planets on the other side of the galaxy or different galaxies. I just don't see it. I don't see how it's possible. Maybe it's possible.
No, I agree with you there, brother. I do, because you've got to deal with the whole time thing it would take us with our current propulsion systems to get anywhere. Me and you ain't going to get anywhere, right? So I think it probably is like you. I agree. If we were going to send things out far, far away, I believe it would be a probe. It would be, even if a robot's on there, just some kind of AI package just to steer the thing, to communicate back what it finds. I definitely don't see us humans, unfortunately. I would love to think we could. But in our current shape and form, and with our current physics as we know it, I just don't think it's doable to go interstellar. However, I think we might be able to.
We have gone interstellar, though. That's interesting. We already have.
Ah.
With Voyager.
Voyager, yes, indeed, it left the solar system. Now imagine me and you sitting on the Voyager if there was a capsule in there. How old would we be by now? Or would we? Well, we would age because it's not going near the speed of light, right?
No, we would probably age about the same we'd age here. We would be dead by now, I think.
Well,
I don't know when it launched.
Quick one before we go to the break, right? I don't know if you've heard of Dr. Craig Venter. I'm sure you have.
I haven't.
All right, he's one of these, I call him crazy bioengineers. He's playing about with genomes, and I think he was one of the first people to basically sign his name or put some markers into DNA. And he has given a presentation at NASA Ames before about deep space travel. Now, he came up with a very novel and weird science way of going about it. But he was talking at the time, like we are, about the way humans in their current form, we can't go long distances. We can't think of these interstellar kind of things unless, and get this is weird, but he was saying we could maybe find a way of splicing in some cockroach DNA to our future astronauts so that, like the cockroach, they're more able to withstand the high levels of radiation that might be experienced. Now, I get it. It was a presentation. I'm sure he wasn't literally going back to the lab and splicing a human with a cockroach. But still, I thought that was quite a novel idea.
Yeah, that's something they'd have to do in China.
Yeah, they probably are.
They probably are.
Well, they've got the first pig. Was it pig monkey embryo or something they've done over there now? Literally chimeras. No, yeah, they're working on the chimeras. And I know there was a person, a scientist in South Korea, who was cloning domestic pets. Now, he decided, you know what, I can only go so far with my cloning technology in South Korea because obviously there's ethics and things like that. Whereas in China, maybe just a little bit more relaxed up there. So he upped sticks and he moved his operation, his lab, whatever you want to call it, up to China so that he could have a more broad range of cloning potential. So definitely, China would be the place to go.
I might have to get this guy on the podcast. Is he still alive? When was this presentation?
Craig Venter, dude, he's super, super, super famous. He really is. And I know he's more biological than physics, so I understand that you probably haven't heard him that way. But yeah, he's a really interesting cat. He really is. I think he was one of the first, like I say, he was one of the first people. And I'm trying to remember, this was years ago, but he either signed or put some marker into DNA that made it totally his. Like he patented his DNA or some weird thing like that. I'll dig it up during the break because I hate to leave the audience thinking, what the hell was Kev talking about there? But yeah, Dr. Craig Venter, myself and Joe Joseph, we really do view him and somebody called George Church as absolutely your stereotypical crazy mad scientist, dude. It's some weird
I
stuff.
think it'd be tough to like find the pieces of DNA that you needed to change.
Hey, with CRISPR and everything else, who knows, my man? Who knows what's just around the corner? But when we come back after the break, we're going to be blasting off into space and we're going to be taking a look at the hunt for exoplanets, where maybe, or maybe not, my life exists. Don't go anywhere, folks. We'll be back in 3 short minutes. Now, Brendan, we are still very, very live on
Yep.
YouTube right now. So what I'm going to do is I'm going to dig up this thing on Dr. Craig Venter so you can see it, okay? Like I say, very, very famous chap. I don't know if you can see him there. Biotechnologist, a biochemist, and a geneticist. He's known for leading the first draft sequence of the human genome and assembled the first team to transfect a cell with a synthetic chromosome. There you go.
Mm.
Yes, that's the crazy scientist there, Dr. Craig Venter.
Craig Venter.
He
I'll
is
have
the
to remember that
founder
name.
of the Human Longevity Inc., which is a San Diego based venture launched by Craig Venter and Peter Diamond in 2013. The goal is to build the world's first or most comprehensive database on human genotypes and phenotypes, and then subject it to machine learning so that it can help develop new ways to fight diseases associated with aging. Yes, these are what I would call your transhumanists trying to cheat death and making us live long into the future.
Yes.
Don't you
Man,
turn
that's
out don't you turn out a crazy scientist like that, dude?
maybe I will. We'll see. If I keep talking to you, I might.
You might, but like I say, if we'd spoke 4 or 5 years ago, you'd have thought to yourself, that guy must sleep in a tinfoil hammock. I thought everything was a conspiracy, dude. I really, really did. But
I
over
was
the
there.
years,
I used to be that. I used to be the same way.
yeah, over the years, I've
I
come
remember
to
I used to
realize.
listen to. Do you remember when Alex Jones? Man, he had a. I still remember what the studio looked like. I used to listen to Alex Jones for like 4 hours a day.
Yeah, when he had the curtain and everything before he went into the Texas Command Center, as I call it. I can't really
Yeah.
watch too much of Alex these days. It's gone way too political for me, you know, and that's not my thing, really. I let people worried about that stuff get on with it.
Yep, I remember when the government was turning the frogs gay. I
Yeah,
remember everything.
but they are turning the frogs gay.
I know.
Well, they're maybe not turning them gay, but some of the chemicals that run off into the rivers is damaging their sexual organs. So again, as Jonesy always does, he finds a way of making things pretty sensational, shall we say, without being
Yeah.
too derogatory to him.
Of course.
Of course. But what's been happening with your experiments before we go back live? Everything going well with the black holes, stuff like that?
Yeah, well, I'm actually sort of transitioning into some new research
All right.
on. Have you heard about nanograv?
No, I have not. No.
Okay, but you know what gravitational waves
Yeah.
are.
Yep.
Okay, so we're working to detect gravitational waves.
So like LIGO, but
A little different. Instead of building huge devices,
okay.
like LIGO does, and spending billions, tens of billions of dollars, we are instead just using pulsars.
Can I ask
because-
you about this when we come back after the break? Yeah.
Of course,
Oh,
yeah.
this is super interesting, dude. That's really cool. And then we can get into our exoplanets. But folks, before we go back live, please, please, please check out Brendan's website, thestateoftheuniverse.com. And that's thestateoftheuniverse.com. He has spoke to some of the leading scientists in the world, folks. And we're going back to the network right now. Here we go. Welcome back, ladies and gentlemen. Brendan Drachler is here with me today, an astrophysicist from Rochester Institute of Technology. And during the break, I was asking him how his work on the black holes was going. We learned in the past that Brendan was working on a simulation to see what would happen when two black holes collide, so that in turn, he would be able to give almost this telltale fingerprint kind of forensic kind of trace to astronomers out there. And then if they were to see something similar, voila, they could basically work out what was going on. But then, Brendan, you told me you've started working on something even newer now. What's going on there?
Yeah, so it should be said, there's hundreds, I think I've said this in the past, but I always feel the need to say it again. There's hundreds of people working on those simulations alongside me. And I don't want to give anyone the impression I'm sitting alone in a laboratory trying to, come up with groundbreaking cutting edge physics. There's thousands of people doing this stuff as well. So shout out to all them. But yeah, I'm switching into a new sort of paradigm. So we've talked about gravitational waves on the show before.
Yep.
Everyone knows what they are. You're talking about tiny ripples in space-time caused by two black holes merging or two neutron stars merging or a variety of other things. One of the coolest things is that there's probably so you've heard of the cosmic microwave background, Kev?
Oh yes, Brian.
Could you tell me could you tell me what that is? Do you know?
The cosmic background radiation? Is that what's left over from the Big Bang?
So it's emissions. It's essentially, it's the emissions that began when the universe started to become transparent, we'll say.
See, you've got a far more scientific way of putting things, Brendan. This is why I need you here, man.
Yes, well, it's important we call it the CMB, the cosmic microwave background.
Yeah.
So it's a background made up of microwaves. Microwaves are a frequency of light, a spectrum of light, okay? And the microwaves that we detect teach us about the early universe. Well, something very similar happened because, as you might imagine, the Big Bang, you had this incredible expansion of the cosmos in all directions simultaneously at the same time. You might imagine that did things to space-time the same way that merging black holes does stuff to space-time. And we theorize that it did just that. We theorize that there should be a cosmic gravitational wave background. So there should be gravitational waves at some frequency hovering around in the background of all of space-time. And if those are there, Kev, we can finally put the nail in the coffin of inflation. So the goal is to detect them. The question is, how do you detect them?
I was just going to ask you, how in hell's name do you go about that?
Yes. So LIGO, you know what LIGO is?
Yeah.
Essentially what LIGO does is it shoots lasers down a giant beam in this direction, in the direction of my camera, and it would shoot another one down a giant beam in a perpendicular direction, and it would bounce them off of mirrors, and they would come back, and ideally they would get back at the exact same time, because if you make sure that the beams are the exact same distance, you know that light travels at an identical speed, okay? No matter which direction you send it in, light is going to travel at the same universal speed, so you should expect that those beams get back to you at the same time. And it turns out that they do all the time at LIGO. They do 99% of the time. You shoot a beam down, it comes back identical. But there are some times, if a gravitational wave is passing, that one of those arms will literally shrink, okay? And it will shrink by a tiny, tiny amount. It'll shrink just barely because a gravitational wave is passing through. And it is that tiny shrinkage that will cause light to either get there before or after the other light beam. So the light that I sent this direction will get back there sooner than the light I sent that direction if a gravitational wave has passed. That's in essence what LIGO does. Okay? Yeah. It's a very simple thing to think of. There's a reason it took 25 years to implement. There's a reason that there's so many intricacies. There's a reason there's 1,000 people working on it. It's a lot harder in practice. But in essence, it's a simple procedure. In fact, just a plug, Kev, I had the Nobel Prize winning physicist, Dr. Ray Weiss, who was the pioneer of LIGO on my podcast. I encourage you guys to check that one out.
Oh, I was plugging your website earlier on today. I was scrolling down all the guests you've had on, showing our audience the kind of caliber of guests you get on, because I think that speaks volumes to the work you're doing. And whether it's Ron Weiss, as you say there, or any of the other guests you've had on, brother, I mean, some of these people are at the very top of their fields. They really, really are.
Yeah, that's the idea. The idea is to speak to scientists and to humanize them. My most recent episode, I talked to Dr. David Fisher, who's a spaceflight historian, probably the smartest, most knowledgeable person in the history of spaceflight ever. Like ever. This man is incredible, the amount of shit that he writes and speaks about and has written throughout his career. We're talking thousands of pages per year in documentation of everything that happens in spaceflight. And that's a great episode too. I encourage people to check it out. But anyway, LIGO. In essence, you understand how it works. Now, Kev, in order to detect lower frequency gravitational waves, like the kind we would look for from the formation of the universe, we would ideally want to make our detector bigger. And that's what LISA is trying to do. ELISA, have you heard of that?
No.
Okay, so this is a really cool concept that done by the European Space Agency and some collaborators, which I think is going to launch in the 2030s now. But it's going to be a gravitational wave detector in space. So this is awesome. So what they're going to do is they're going to send, you can look up LISA on Google, and I can explain to you, because the picture's very helpful for people just listening on audio. Try to look up what LISA looks like. I'll explain it some, but yes. So go to images for us.
Yeah.
Okay. So this one's fine. So you see this little triangular circular thing. What we're going to do is we're going to take these, 3 of these, and we're going to put them millions of miles apart from one another in space. And we're going to shine beams from one to the other and back and forth. Okay? And these beams are going to do exactly what LIGO does, but instead of shining light on just such tiny scales, we're going to send it on huge scales, really long scales. And that's going to help us detect even lower frequency gravitational wave signals. Okay? Now, what's really cool, okay, is that what I'm transitioning into working on is something completely different, where instead we use pulsars, because we've talked about pulsars on here before, Kev.
Yeah.
You know that there's such thing as millisecond pulsars.
Yep.
And that means you have a neutron star that's spinning, and it's the most precise clock that you can come up with outside of quantum clocks or some of the nifty stuff people are coming up with today. But it is an incredibly precise clock. It spins at such an incredibly precise rate. It slows down over long scales. But for our purposes, it's incredibly precise. And so what we're trying to do is find a bunch of these pulsars, and people have already done this in collaborations all over the world. You could search pulsar timing array, and this is an effort that's been being pioneered for a long time. And maybe there will be an interesting graphic when you search this that your audience might enjoy. Yeah, so click, yeah, so this is a good one. So you have all these pulsars out in space, and they're all shining a light towards the Earth, okay? The question is, can you detect, they should be perfect clocks. They should go tick, 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 tick at the exact same time every single time you look.
Yep.
They should have the exact same time of arrival, as we call it, every time. There should be no deviation, or at least an incredibly small deviation. So can we look at that and can we say, oh, wait a minute, that pulsar ticked too slowly, therefore a gravitational wave passed? Is that a thing that's possible to do?
Well, I mean, it does seem to make sense. I see where you're coming from, yeah.
So, in actuality, it gets tough. And the reason it gets tough is because there's a ton of stuff obstructing our view to pulsars, stuff that you don't even see, like dust, gas, stuff that the light has to go through. We don't have a pristine environment like we do with LIGO. LIGO's nice. It's in a vacuum. We can seal it off. We can make sure nothing weird is going on. We have control over it here on Earth. Pulsars are a little weird. We also know that pulsars have weird stuff going on with themselves. Some are in orbit around other objects. There's a bunch of weird stuff that has to be taken care of in order to do this correctly. And so that's the work that I'm transitioning into now. It's incredibly exciting, and they expect to detect gravitational waves, potentially the type that will prove the inflationary period of the early universe in the next 10 to 20 years.
You need to get your name on the top of that paper when it comes out, because I want to be able to say I've got like a Nobel winner on my show, or I've had a Nobel winner on my show before you get far too big to hang out with a conspiracy tard like me.
Oh, I'll always hang out, Kev. Loyal. That's loyalty, man. You helped me build my audience by having me on here. We'll always make time for the Kev Baker Show.
Oh, brother, honestly, I love that you come on here. I really do. Now, with something like this, let me bring up another story that we're going to get into tonight then. Because we've got this weird star, Betelgeuse, Betelgeuse, whatever people want to call it. And when this dies, will that send out gravitational waves?
Supernovae can send out gravitational waves.
Okay.
They can, and will we be able to detect them? No, not with the technology we have now. We have to use different types of detectors to detect different types of gravitational waves. Unfortunately, LIGO is realistically only good at detecting binary neutron stars merging and binary black holes merging. In the future, we'll have different types of detectors that can detect different types of. It's just like telescopes. It's literally just like telescopes. In telescopes, you have different telescopes that detect different frequencies of light. With gravitational wave detectors, you have different detectors that detect different frequencies of gravitational waves. It's the exact same identical phenomena. And so, yes, supernovae can produce gravitational waves. And that's an exciting thing because, in the future, you could imagine that a supernova goes off and we get a detection and then we get an alert. We can get an alert because the gravitational wave is going to get here before the light does. And the reason that the gravitational wave will get here before the light does is because as soon as the supernova goes off, those gravitational waves are going to be sent out, flying towards the Earth at the speed of light. Meanwhile, because the interior of the supernova is going to be so dense, light itself is literally not going to be able to escape right away. It's going to bounce around. It's going to bounce in between other particles for a long time. And this happens with the sun. There's an interesting number. I don't remember what the number is. It's not a very precise number, but nevertheless, it illustrates my point. It takes, I think it's on the order of millions of years for a photon created at the sun's core to get out of the sun, which is incredible because it's just bouncing back and forth off of particles. And that same thing will happen in supernovae most likely. So imagine, Kev, in the future, we get an alert that a supernova has gone off. And we get to point our telescopes at it and find it in the sky before it actually blows up. And we can watch the entire process. That's cool.
That is very cool. Very, very cool. And we compare that to the likes of... how do you pronounce this? Is it Betelgeuse? Betelgeuse?
Both of those are actually fine pronunciations. Those are the two that are really popular in the world of astronomy.
Betelgeuse that'll do me because Anne's mum, my partner, her mum used to call me Beetlejuice from that crazy film from years ago because she thinks my head's too small for my body, but that's another story altogether. But this actual star, I've heard about this being talked about a long, long time, and the potential for it dying, going supernova, whatever the correct term is. Where are we with Betelgeuse right now then, dude? Because they're saying that it could be imminent, but how long will it take for us to really detect what's going on by the time the light gets here?
Well, it's super... Well, okay, so it could have already gone supernova, right?
Okay.
It could have already supernovaed. And we because remember, I don't remember how
we're
far
looking back in time, really, aren't we?
Yes.
Yeah.
Yes. I don't know how you can look that up pretty readily. I think if you go on the Wikipedia page for Betelgeuse,
I'll find that
probably,
just now. Yeah, you keep talking.
You can
I'll
probably
find
see how
this
far away
now.
it is. But so this is a star in the constellation Orion. Orion is a incredible constellation. It's one of the only ones that I think actually makes sense. So if you scroll down, it should be on the right here. They're pretty good at putting these on here generally.
700 light years.
Yeah, approximately 7. So okay, so if Betelgeuse blew up in the last 700 years, we wouldn't know yet.
That really blows my mind when we start talking about things like that, dude. Almost like when we look into the night sky, we're literally looking hundreds, sometimes thousands, sometimes tens of thousands of years into the past.
Yes, it's a weird thing. But if you pull up that picture again that you had up in the article that I sent you,
yep.
It's if you've never gone out and looked at Orion, you should go out. Anyone listening, if you're in the northern hemisphere, it'll be in the night sky tonight, and every other night, pretty much from now until like April. If you're in the southern hemisphere, you'll have to wait until winter time. But it's an incredibly, and also in the southern hemisphere, it appears upside down. So do you see how it looks like a guy?
Yep.
On the right there, it looks like a man. Orion the Hunter is its name. In the southern hemisphere, it appears upside down, and so I don't know what the ancient tribes have considered it, but you can see it kind of looks like a dude. And Betelgeuse is the shoulder, the left shoulder of that hunter. Yep, that one right there. And it is the 11th or 12th, depending on what literature you look at, brightest star in the sky. It's incredibly bright, and you can see it when you go out. And in fact, I believe that's Sirius. If you look off to the left,
Yeah.
that is, I think that's Sirius. I don't know if I'm right about that. I'm pretty sure it's Sirius, and that's the brightest star in the sky. But we know for a long time that Betelgeuse changes brightnesses. It's a variable star. Its outer layers are literally dimming, and they're dimming because they're actually pulsating. They're actually like literally changing size, which is incredibly cool. And the reason they're doing that is because it's in essence the gas in the outer layers of that star, and all stars of its type, which are red giant stars, are convecting, and they're almost acting like a boiling pot of water. It's incredibly fascinating how these things are able to stay stable and still do this convective stuff. It's fascinating. And so you literally have the star changing size. Now, this is the dimmest we've ever seen it in a century of observations. And it got a lot of people talking like, man, what if this thing is about to blow up? You know, what if this is a supernova that's about to go? Because we know that it will supernovae one day. We know that it will. And when it does, it's going to be as bright as the full moon for a few days. It will dim quite quickly, but it will still be incredibly bright. You will be able to see it in the daytime. And I hope, first off, I hope there's no life around it. I doubt there is. I hope there's not. And then to my next part, I don't want to offend anyone living around Betelgeuse. I hope it blows up in my lifetime, because that
can we
shit
call
will be.
people that live around that? Can we call them beetle geezers?
We can call them juice heads.
Juice heads. I like that. Yeah, I like that.
Yeah.
Dude. But I was going to ask you, do we know if there's planets around Betelgeuse?
No, but it's very unlikely that there's potentially planets. I don't know anything about the planets, but it's unlikely that there's life.
Yeah.
And it's very unlikely that you'll find life around any massive star. And the reason it's unlikely you'll find life around massive stars is that they don't tend to live very long. Their life cycle is pretty short. You'll most likely find life around smaller stars like the sun, or even smaller stars like dwarf stars, because it took us 4 billion years to become the technologically advanced people we are today, from the inception of the Earth. So ideally, we would have liked if the sun would have lasted 4 billion years, which it has, and it will probably survive another few billion. But there are some stars that don't even survive 1 billion years. There are some stars that don't even survive, 500 million years. Some of them live very short lifespans because they burn through their fuel so quickly. So it's unlikely that you'll find life around a big star like that.
But we are looking for, or at least we're on the cusp of finding more of these exoplanets. Now, I'm not saying life, Brendan, but the exoplanet search, it's really picking up pace, right? Because you sent me a story about the Tess telescope, and it's having some amazing results, right?
Yeah, actually, it's underwhelming. That's one of the interesting things. It's already detected at like 1,500 exoplanets or something. That's the number that's coming to my head. It might be more than that. I think they do like periodic data releases. So I don't think any number that's public is actually
up to date,
a real number, an updated number. I think they only update their numbers every few months or something. Nevertheless, we're talking 1,000, maybe more than 1,000 exoplanets it's discovered. That's underwhelming, because when we launched it, we expected it to detect tens of thousands of exoplanets. So one of the reasons it's not detecting as many exoplanets is because it's sort of biased towards detecting. I should say the reason it's not detecting many interesting exoplanets is because interesting is a relative term that I use to describe, like a tiny Earth-like planet. Excuse me.
So are they only really looking for planets that conform to Earth, i.e. only in the Goldilocks zone, only with certain kind of qualities about it, and that
No.
It's not like that then, no?
No, they're looking for anything they can get. And that's how these searches are done. So Tess literally just, is in an orbit around the Earth, and it is looking. It's just looking out there with cameras that just don't turn off. They're always looking. It has one that points up, down, straight ahead. It like scans the entire
Yeah.
sky in front of it, and it goes around its orbit, and it just looks out, and it looks at the same stars every time it orbits, and it looks at the same stars, and it's just looking for one of them to dim just ever so slightly. And if it detects a dimming, well, it will look again and again and again, and it will try to detect, is this dimming due to planets? Okay? Because if a planet goes in front of its parent star, the transit method, we've talked about it 100
Yep.
times on here. It's the way in which we do most detections today, and probably will do detections for a long time. It's the most obvious way to detect exoplanets. And so that's what Tess does. It just goes in orbit. It scans thousands of stars. It looks at them. It tries to detect if any of them are dimming. And if some of them are dimming, then either a human takes a closer look, or a computer algorithm takes a closer look and tries to detect, is this an anomaly? Is this a real thing? It's very simple, and it doesn't care. It could be a Earth-like planet. It could be a dwarf planet. It could be it's not going to detect any dwarf planets, probably. They're too tiny. It could be a super Jupiter. It could be a Uranus type planet. It could be whatever.
I'm just looking at this headline here because this excites me. It says NASA's Tess Planet Hunter finds its first Earth-sized world. And not only that, but it's in the habitable zone. Now,
That's right.
Should I be getting excited now? Can I turn around and say, come on now, Brendan? If we
You
found
can,
this one, there's
and
many like
the
it.
reason you can is because also, this is really interesting, it's also in orbit around a star that we would expect to find life around. Earlier I was talking about how we don't expect to find life around big stars. The star it found it around is actually an M dwarf star. So it's a tiny star that is going to be very stable for a long time. And the star, I think I read in a paper, doesn't appear to be doing any weird outgassing. Okay, so some stars are pretty violent. Not all stars are nice like the sun. Some stars are pretty violent, and they outgas, and they have incredible solar flares that would kill any life around them.
Yeah.
This one appears to be a nice, stable, beautiful star, and in its habitable zone appears to be an Earth-sized planet. Now, that's pretty damn cool.
Very cool.
What we haven't ruled out yet is what the planet is like. So this is obviously just a sort of a made-up rendition of what the thing looks like. We're nowhere near the point where we can directly image exoplanets. We don't even know if this planet is mostly gas. We don't know if it's like a Neptune. We don't know if it's like the Earth. We don't know if it has water or an atmosphere. We don't know how hot it is. We don't know any of that.
So, Brendan, how do we begin to narrow that down? Do we have the technology to do that yet, or do we have to wait for the James Webb to go up there?
We don't quite have the technology to do it. There's some cases where we can like do an okay job if we're really clever, but if I were you, and I personally don't, I wouldn't trust many studies you see or hear about where people have said that they found what. Do you remember, this might have happened a few months ago, I don't remember if we talked about it. There was this article that was in Nature, I think, or Science, or one of the big publications, and it was like, we found an Earth-sized planet and it has water in the atmosphere. Do you remember that?
Yep.
Okay, don't trust any of those for the foreseeable future, because we simply don't have enough data points. Here's the problem with that study in particular. Any viewers can go and look at the actual data. They have like 10 data points, man. You can fit any kind of line you want to 10 data points. You can make any conclusion you want from 10 data points. 10 data points doesn't help anyone,
And
10 data
I would
points.
imagine confirmation bias might sneak into this as well. If you're determined to find one of these Earth-like planets, then with 10 data points, maybe that's going to fit exactly what you think, or you can stretch it to fit what you already think is there. Is that what we're seeing here?
Yeah, well, okay, this is essentially how that study works. So imagine you have 10 data points and they're like in a certain, line. Let's imagine you have 10 data points and you have like a data point, data point, data point, data, and it kind of looks like a parabola, it goes down and then comes back up. Let's just imagine that that's the spectrum you get, right? When you're looking at this thing. You can try, what happens then is you have this, what you've observed, and you try to fit a model to it. You try to say, okay, what would a planet look like if it had water in its atmosphere? And so you can use a computer to simulate that, and then you say, oh my God, the planet with water in its atmosphere would look just like the one we observed. But here's the problem. There's an infinite number of molecules that you can ask that question about. So why then are you stopping at water? Why don't you ask yourself, what would it look like if there was carbon dioxide in the atmosphere? What would it look like if there was oxygen in the atmosphere? What would it look like if there was helium in the atmosphere? And what you'll find is that with 10 data points, you can pretty much make the assumption that anything could be in the atmosphere. You understand what I'm trying to say?
Yeah, absolutely. And again, it's that confirmation bias then, because
Yes.
they're looking for that. We're on the break, folks. We'll be back in 3 short minutes. Remember to check out Brendan, thestateoftheuniverse.com. Don't go anywhere. We'll be right back. There we go, man. We're on a quick break again. Now I'm going to put on some tunes for a couple of minutes, folks. I'm going to go and fill my cup up again. And then when we come back, we'll get right back into it. And when we come back after the break, Brendan, where do you want to pick this up?
What did we just stop talking about?
We were talking about the crazy graph with 10 points.
And exoplanets. I got you. Okay, we can continue talking exoplanets if you have anything to talk about in that regard. Yeah, we can continue talking exoplanets because you and I always talk about how this idea of habitable is kind of a bullshit idea.
Yep.
Because life can be pretty strange.
Life can take many ways, shapes, and forms. Absolutely. So I'm going to put on some music, folks, and we'll be back in a couple of minutes. I'm just going to go and refill my coffee cup before I dry out here. Remember, check out thestateoftheuniverse.com, and I will get Brendan to give you some of his links when we come back, i.e. where to follow him, where's the best place. So until then, chill out, kick back, and I will put on some crazy tunes. Here we go. Welcome back, ladies and gentlemen. Hour number 2 on today's show with Brendan Drachler, yes, indeed, our astrophysicist from the Rochester Institute of Technology. Before the break, we were getting into exoplanets and how Tess had discovered one of these Earth like planets. Or is it? Or is it? So let's pick up the conversation there. And I'm looking at one of the other stories that you sent me. I don't know if this is the same thing. I don't think it is.
Nope.
But NASA.
I was just thinking. I didn't even know I sent you that one.
Yeah,
But it's a cool
NASA.
story nonetheless.
NASA telescope discovers its first planet orbiting two stars. Talk to me about this, dude. This is interesting.
Yeah, this isn't the first time we've seen this, but binary star systems are common, way more common than we thought. We used to think that we were common, just kind of stars hanging out by themselves in sort of remote areas of the galaxy. That's not the case. It's more the case that a lot of stars are binary stars. They form in pairs. I mean, if you think about it, stars just form out of gas clouds. What's to stop a gas cloud from forming multiple stars at one time? And those stars are close enough together to interact and form a binary.
Now, Brendan, I've heard it been said, and I don't know how true it is, but I've heard it said that our solar system is actually quite rare. The fact that we have one star, one sun. What do you say to that, though? Because I think the universe is that vast. I'm sure if we looked long enough, we would find many kind of solitary star systems.
Oh, the universe is big enough that if you look, you'll find every possible configuration ever.
So we're not
You know?
that uncommon then. We're not that rare a thing just to have the one star then, no?
No, it's not certainly not a rare thing. But it's also not rare to have two,
Okay.
right? The point you make is a valid point, which is that the universe is so damn vast that if you look anywhere, chances are you'll find any weird configuration you could think of.
Yeah.
I believe we have found planets going around triple star systems already, which is mind-boggling. Imagine being on that planet.
I was
and
just going to say, can you
stars.
imagine how that would be? I mean, I don't think we can even comprehend what that would be like. Hard for us to kind of visualize that, right?
Yeah, I mean, it would be exactly as you'd expect. It would be you'd have nighttime. Well, presumably you'd have nighttime, assuming you orbited around all three.
I was going to
and
say,
you
well,
didn't
if you're
just like
stuck
orbit
in
around
between
one.
two of them, if you're stuck in between, yeah, that'd be weird, right?
That would be weird, and you also would have a very chaotic orbit.
Yep.
So you wouldn't just go in like an ellipse around one of the stars. You would be, if that was the case where you were somehow orbiting between the two, then it would be like your years would change. It would be very odd. It would be very odd.
Very, very weird indeed. But this one here that NASA have found, I mean, is this exciting scientists out there that they've actually detected an exoplanet orbiting two stars?
I think it's pretty damn cool. I think it illustrates the fact that the universe is insane. And, there's no guarantee that there's not life on one of those type planets too.
You see, this is why I'm still very open to the fact that there could be other intelligent life out there. Because it's just so vast, And if it can take hold on this planet, then what's to say it can't take hold on another planet? And then there's various
that's the thing,
shapes and forms,
As soon as this planet became habitable, as soon as we had, an appreciable atmosphere, as soon as bombardment stopped,
Yep.
heavy bombardment in the early solar system, as soon as all of that stopped, life formed, like almost immediately.
Yeah,
it
I was
formed.
reading that somewhere the other day. It was almost like instantaneously once, and it was talking about the bombardment and everything else that was going on. But once it settled down, that was it. Boom.
Yeah,
Life
I mean,
took off.
it took 4 billion years to create us, but the point is, life can take hold seemingly very easily. Now, of course, once again, we have a sample size of 1, so we have to be careful. But I suspect that life is probably a lot more, we'll say, malleable than you expect. Is that even a word? That doesn't even sound like a word.
Yeah, I think it is. I've heard it before, and because we've heard it before, we're gonna go with it. I like it.
All right, it's
But
a word now.
there's
Malleable.
a story here that I had come across the other day from theconversation.com, and it says here, the idea of alien life now seems inevitable and possibly imminent.
Right.
And just to
Yes.
read the first part here, it says extraterrestrial life, that familiar science fiction trope, that kitschy science fantasy, that CGI nightmare has become a matter of serious discussion, a risk factor, a scenario. And how has ET gone from sci fi fairy tale to the serious scientific endeavour modelled by macroeconomists, funded by fiscal conservatives, and discussed by theologians? Because following a string of remarkable discoveries over the past 2 decades, the idea of alien life is not as far fetched as it used to seem. Discovery now seems inevitable and possibly imminent. How can we say it's imminent? I don't know how they can predict that it's imminent that we find it.
Yeah, well, I don't think anyone's predicting it's imminent. But you know what we were talking about, the vastness, and this is an op-ed, I assume, a scientific one. They're not just providing opinions; they're providing science to back their opinion. Seems like a good piece of writing. But yeah, they're talking. I imagine they're talking about Mars. They're probably talking about Enceladus. They're probably talking about Europa. I would imagine they're talking about all of those things. And it does almost seem okay. One of two things is going to happen. Either A, life is common, like we talk about, and it can live in all sorts. I mean, we know on this planet alone, it can live in water temperatures above boiling. It can live in water temperatures below freezing. It can live in the most acidic environments on the planet. It can live in the most dry environments on the planet, on the wettest environments on the planet, in the saltiest environments on the planet. It can exist in every extreme place you can ever imagine life being.
Under the unimaginable stresses as well, like in the deep sea, the deep ocean, life flourishes there. It really is. I mean, it's really amazing when you think about the kind of conditions that you can find life in, albeit microbial or whatever. But that's how we started, remember? So, again, I think it's common life out there.
Yes. And just like they're saying in the beginning here, it's just chemistry. It is just chemistry. I mean, organic molecules are found everywhere. The things that make up you and I.
I've heard it been said as well, Brendan, sorry, but even the Voyager not the Voyager, but one of the earlier missions to Mars, like way back, there was even talk then that they'd found life on Mars. And then it all kind of went quiet. And I'm talking like maybe 80s time. I've heard people talking about this when they talk about the hunt for life.
Yes. This is, I know exactly what you're talking about. And we could not, at the time, we were very, what is the scenario that I don't think it was Mars, was it?
Mars might have been in my head, but it might be wrong.
There was a scenario with the moon, I remember, where we had found, microbial life in some soil samples, I believe. And we could not determine if they were contaminated because at the time we were incredibly bad at like being careful, being clean. We talked about the clean room at Goddard Space Flight Center, right?
Yeah.
We've talked about that before. We are incredibly clean now. We now know the importance of, maybe when we do this next Martian return mission, if it ever gets off the ground, we will be able to identify biological life in the soil of Mars.
I think that day is coming very soon. I mean, that's just my opinion. I've got nothing really to back it up with, but I think it's coming soon.
No, I agree with you. We've already found organic molecules in the water that is being shot out of the surface of Enceladus. We've already found it. It's already been done. So we already know that the building blocks for the very life that make us up, the very molecules that make us up, already exist in other places that presumably can have life in them.
And if that's just within our own solar system, right?
Exactly.
Yes. You've got to think that there will be other forms of life. And I'm not talking intelligent here. I'm just talking microbial, the kind of stuff you're talking about. I think the universe is probably rife with that kind of material.
Oh, I think so. Yeah. I don't think I would bet any amount of money that I've ever had that there's life somewhere out there. I would bet that there's even probably complex life, like something beyond bacteria, something beyond molecular life. There's probably something weird out there somewhere. Is there intelligent life? Are they flying to us and visiting New York City and, being caught on video by some 16-year-old kid in Crimea? I don't know. I don't know any about that. All I know is that there's probably life out there on a planet somewhere, on a moon, on something far away. There's probably many instances of it. I would guarantee there's many instances of it.
And when we send up the James Webb then in 2021, how is this going to improve our knowledge of the night sky, these exoplanets and everything else? What's the big leap in technology that we get with the James Watt telescope as opposed to Tess that's doing its thing right now?
Well, the James Webb will not aim to discover exoplanets. It probably will discover a few, but it's not its goal. It's not an exoplanet searching spacecraft the way Tess is. Tess's sole mission is to look at stars and try to detect exoplanets. What James Webb will allow us to do is take those exoplanets that are closest to the sun, closest to the Earth, and try to image them directly, literally look at them, get spectra from them, see if they have atmospheres, answer all of these open-ended questions. And then you I don't know if you mentioned this. So this might have been in that article you sent, and I skimmed through it, and they were talking about James Webb. I believe they were talking about James Webb.
Yeah, they mentioned that at the actual end of the.
Yeah, so they mentioned something that's interesting.
Yeah, it says the James Webb.
And it's something called a star shade. This is a really cool thing.
Yeah, this thing here, it says the James Webb Telescope planned for a 2021 launch, which we've talked about before, which is going to be a very precarious operation anyway.
Yes.
To get this thing opened up and working. But when it does, it will be able to take measurements for some of the Earth-like worlds already discovered. It says just a few years later will come space-based telescopes that will literally take pictures of these planets directly.
Exactly, and that's going to use a sort of a new form of technology called a star shade. This is a really interesting thing. So one of the reasons we're unable to detect a lot of exoplanets, image. I almost closed Skype by accident. One of the ways we're able to image. The reasons we're not able to image, now that I know how to use words, is because the star that is around this exoplanet is essentially the only thing we can see. That's it. If we, it's like if Mercury is next to the sun and you look at the sun, you don't notice Mercury is there. Okay. What you don't know is that whenever the sun is up there in the daytime sky, Mercury is right next to it, or going around it, or behind it, or near it, all the time.
Yep.
You don't see it. You don't ever see Mercury. You don't know it's there. You have no clue. When can you see Mercury? You can see Mercury during a solar eclipse. And the reason you can see Mercury during a solar eclipse is because you have some object that blocks out the sunlight so that you can see the objects around it. Now that's how
we put our hands up to our eyes when the sun's bright and we're trying to see something. That shade allows us to see.
The exact same idea.
Yeah.
So what a star shade will do is it will sit in front of a telescope, tens of thousands of miles in front of a telescope, and it will sit out there, and it will, in conjunction with the telescope, go in front of a star, okay? And so it blocks the light coming from the star, so we can see the environment directly around the star. That's the idea. And with that idea, we will be able to directly image some exoplanets.
That is pretty exciting, dude. Very, very exciting indeed. So I don't know where you want to take it next, Brendan. I know we've got to talk about things closer to home, but before we deal with that, is there anything else space-related that you had pulled up for today that you wanted to get into?
I don't think so. I thought about this earlier. Something I wanted to tell you about because you're the type of person who just loves science, and I thought
it excites me, man. It really does. Sometimes I don't necessarily understand all of it, but
yeah, I don't know if you have ever heard. Does the name Verona Rupes mean anything to you?
Absolutely nothing.
Okay, do me a favor and go to Google and type in Verona.
Right.
Space RUPES. Okay, this is an incredibly cool thing. I was reading about this, I don't know, probably last week, and I just thought of you. it's a cliff, and it is the largest cliff to planet size ratio in the entire solar system. Okay, and this was discovered a long time ago, and I didn't know if you'd ever heard of it, but I figured if you didn't, then you'd find it incredibly interesting. So this is on a moon of Uranus called Miranda. Okay, how it's formed, no one knows, but it is incredibly cool because this cliff, Kev, would be if you were to, it's like something like 10 miles high.
What?
And if you were to jump off of it, this is the coolest part, I think. If you were to jump off of it, because the surface gravity is so low, the surface gravity is like less than 1% of what the surface gravity is here on Earth, because it's a small moon. If you were to jump off of it, the gravitational force would be so low that you would barely fall. So you would be in free fall for over 10 minutes.
Wow, dude.
That's awesome.
That's mind-boggling.
So, and the other cool part is you'd get to the bottom and you would only be going about 100 miles per hour. So if you wanted to like devise some space tourism where they bring you here and you jump off, all you would need is like a sufficiently large sized airbag and you'd stop without hurting yourself.
Oh, then where's this again?
This is on a planet not a planet, a moon Miranda.
And where's this moon?
Uranus, around Uranus.
Dang, dude. I had never seen anything like this before.
So this is a fake picture, the one you're looking at. But if you look at, I think the one on the top left, that's a so here, this is the actual picture that was taken. So you can see the cliff here. You're looking at it kind of like Google Earth style. It's insane. Do you see the area I'm talking about?
Yeah.
Yeah. So I thought I saw this last week, and I read about it before. Carl Sagan always talked about it in his books. If any of your listeners have read that, because it's just one of those cool things to talk about, and that's in the solar system. And I thought immediately about you because I'm like, man, Kev would find this so damn fascinating.
I am absolutely gobsmacked, dude. Totally gobsmacked. This is something I'll be looking into more when I get off the show today. And folks, it's called Verona Rupes Rups. It's Verona space Rupes. The Miranda's Towers. Wow.
Yeah, so this entire moon is like made up of just these like huge jagged fault lines and cliffs and things like this. And no one's quite sure why. Either it was nearly ripped apart in some tidal event, so it got too close to another large body and nearly got shredded, or it collided with something. No one knows, frankly. There's some ideas, and I think that there's some prevailing ideas, but it's weird. It's an anomaly. It's a weird one.
Very, very, very weird. I mean, I've never seen anything like this. I've never heard of this before, and I'm glad you thought of me. I mean, looking at the pictures of this thing here, that is one weird-ass moon up there.
Yes,
it's crazy looking.
Yeah, it's crazy. What about Mimas? Have you ever heard of Mimas?
No.
Man, the moons of the outer solar system are some of the most interesting things. So look up Mimas. There you go. I think you. Oh no, M-I-M-A-S, not
M-I-M-A-S. There we go.
It's a Death Star.
It really is. It's got the indentation and everything, and I'm going to post a picture of that over at TFR, the chat room there, so they can see that.
Yeah, so this is a moon of Saturn.
Oh. You're really adding to my conspiratorial thoughts about these moons now, especially when I see this one, dude. This
what was so interesting is when we had low resolution images of this, and we didn't quite know what it was, because it was at a time where Star Wars was like, really popular.
Yeah.
Like more popular than it is now. I'm personally like, there's some Star Wars fandom now, but I imagine when you were a kid, it was like a whole different level.
Beyond anything you can believe. It was like when I was young growing up, it was me and my best mates. It was everything we ever talked about. All the toys we ever played with. It was before all the consoles and everything came out. It was when you would play with action figures. And I know it seems like a long time ago, and younger listeners will be thinking, what? People played with action figures and things? No, that's how we entertained ourselves. And yeah, the Death Star, one of my best mates, he had the full model of that. And as
Mm-hmm.
young children, we just used to absolutely love all of it. You know, we'd go into different worlds in our own minds, and
Yeah,
looking at
man.
this
I
here,
remember
man.
playing with action figures.
It sounds really weird, but I've actually got goosebumps looking at that moon, dude. It's just bizarre.
You should click that picture in the on the left in the middle, in
Um,
down one,
that one there, yeah, it's a
and
comparison. Yeah.
yeah, that one, man. That's like it's one of those there's so many interesting moons. Moons might be the single most interesting places in the entire solar system. I mean, you think about Enceladus, which do you know what Enceladus is?
Yeah.
Okay, so you have Enceladus, which is literally has these cryovolcanic geysers
At
just
last, at
spewing
last,
water out.
at last, you've mentioned somewhere I know about.
Yeah. Yeah, and you have Io. Io
Yeah,
is a
yeah.
moon of Jupiter, which is like just this most volcanically active body in the solar system. Europa, which probably has a giant liquid ocean
That's the
underneath.
one, me and you, if we had unlimited funding, I think we would send a mission there, right?
Yeah, that's the one that I wish we would go
Yeah,
to.
exactly. I know. But yeah,
I
it seems
think
to be
that
the moon. The moon's the big thing now, right? It's almost like a race to get back there.
yeah, the moon is a huge thing, which I'm fine with because I don't think we ever really did the moon any justice.
Now,
I don't think just
now
going to the moon,
I need to
however
ask
many,
you, okay, because
yeah.
you're studied in this, you're qualified in things, and sometimes I struggle to counter this argument. There are people out there who think the moon might not be real. It might be a holographic projection. And it's not that I want to rubbish anyone that thinks that, Brendan, but as a scientist, what ways do you have of knowing, and what way can I explain to the audience that it's definitely something real? And again, I don't mean to belittle anyone out there or make fun of them. We're all searching for answers, but what would be the best way for me to
So
approach
why
that
do people
subject?
think? Okay, let me ask you this: what are the arguments that the moon is a hologram?
I don't know. I mean, earlier
Like,
on today, I was doing a show as well, and there's people, and again, it's nothing against them because, like I say, we're all on our own paths, and everyone's entitled to their own opinion. I certainly don't know everything, but they were saying even space itself is all a holographic projection. Now, me personally, you know, from the shows I've done with you, I don't personally believe that. But how would you approach explaining that to somebody who maybe thinks that?
I would. I don't know if I would.
It's
That's one
hard,
of the.
right? I know it's
It's
hard.
like I don't know if I would. Okay, people who think that space is fake.
And I
I
don't want to
like
put you
what
on
do
the
they
spot,
think?
Brendan. Don't think I'm trying to trip you up at all or anything, brother. It's just
No,
this
no,
is
no. I don't
something
think
I've
so.
come across. So, and I've struggled to really counter the argument.
No, I've heard about it,
Yeah.
but like okay, the reason you can't counter it is because what people that argue this sort of thing tend to do is they tend to, they tend to put the burden of proof on you, but then claim that your proof is inaccurate.
Yeah.
So they want you for some reason to work on first principles like you're an ancient Greek to prove that the space is not a hologram. When in fact, there's no proof that space is not a hologram because you can't the burden of proof is on them actually to prove that space is a hologram because I can say, that we have images and pictures of all of these thousands of places throughout space. I could say that we have telescopes in space. I could say that we've been to space. I can say all of that stuff. And then the people will say, but I don't believe in any of that. I don't believe in any of your information. Well, we can't talk then. We can't have a conversation then because you're trying to act like our two points of view are coming with the same amount of credibility. Even you said it just a second ago. You're like, and I want people can believe whatever they want to believe. No, they can't actually. When it comes to saying that space is fake, no, I mean, you can say it, but it's not something that you can have an opinion on because it's not an opinionated
I mean,
topic.
it's not something that I can research myself. I mean, I think space is there. I know it's there. I worked with satellites in the army and things, and people will counter that with there's no satellites, but there's nowhere that I can go
Yeah.
to look into this evidence that supports a no space theory. I can't look at anything
No,
that would
it's
support that.
exactly because they
But
try
then
to do this
I'll
thing.
be countered with, but mainstream science lie to us. It's all a lie. And there's no counter argument to that. You can't have a productive conversation.
Exactly. So what I tend to see, we can get into this after the break.
Yeah.
In fact, we should probably just save
Yeah.
what I'm
Well,
about to say for after the break.
how about you give out your links where people can find you, Brendan? And there's a lot of our audience absolutely love your work. Some of them absolutely hate it because you're a scientist, and that's why I like to trigger them by bringing you on once a month. But let people know where they can keep up to date with you, man.
TheStateOfTheUniverse.com. All one word. Easy.
All one word, folks. All
Follow
the best
Twitter,
scientists on
Instagram,
there.
everywhere. YouTube, everywhere.
And to all the people out there that I've just triggered, we'll be back after the break to trigger you some more. Don't go anywhere. There we go, Brendan. We're on a quick break here. Yeah, and again, it's just, I don't like locking heads with people and getting into arguments about either flat Earth or no space. And it's not because I think I'm better than them or I think they're stupid or anything like that. It's just the conversation can go nowhere because you reach a point where any evidence I present, I'm using me here, but anyone who presents any evidence that we are living on a sphere, albeit a kind of not a perfect ball, or if we're trying to say there's space, they'll just say, but that comes from NASA. It's a lie.
Right. So we'll talk about this more when we go back on the air, but the thing that I notice about these people is that they simply don't understand like how scientists work. They just don't understand it. They have a fundamental flaw in understanding the vastness of science. Do you know how many people would have to be in on it for there to be a conspiracy that space is fake?
I don't see. Here's where I come from. I don't. Key bono. Who benefits? Why fake space in the first place? Or why hide that we're living on a plane? Or what? Who benefits from that? And that's where I kind of. And I don't really. I tend to ignore. I tend to steer away from the arguments because I'm not here to divide people or cause trouble. And when you can't have that proper debate, that proper discussion, I don't think there's anything really productive comes of it.
No, there's absolutely nothing productive, which is good that technology continues to evolve in without these idiots. I mean, frankly, like good thing that these people aren't in charge of making policy, because if they were, then we would still be hitting rocks against sticks in order to make fire.
And when we come back, we'll address this further. But any good guests lined up to come on your show in the near future?
We have many topics we'll cover.
Mm-hmm.
I have someone coming on that we'll do a whole show on ancient aliens.
Really?
Actually, which will be interesting. We have some quantum computing people. We have some binary neutron star people.
Now,
we have a bunch of.
You feel more than welcome when you speak to the quantum computing people to send them my way. That absolutely fascinates me, and I think that's the biggest guest I've had on the show. I think, not to put anyone else down or yourself, but Geordie Rose, the guy who's at D-Wave when they invented the D-Wave quantum computer. I think that's probably, if I was to pick 3 highlights, that would be right up there, dude. Right up there. What a genius. Absolute genius. And it was so great to talk to him. It was a guy I had spoken about often enough because of the quantum computer. And when I got to speak to him in person, my opinion of the guy changed absolutely. He was just like you. Just a really keen scientist wanting to create things that don't exist. And I had a blast of a time with him. So I really look forward to hearing your stuff on the quantum kind of computers.
I don't understand people who like think scientists are evil or I don't even know where that comes from.
I was in that, listen, Brendan, I was in that kind of realm for a little while with Geordie Rose, because we were looking at the D-Wave and he was talking, and Geordie himself knows what he's doing, because he was talking about, AI being like Lovecraftian old ones, these ancient beings coming back from other dimensions and things. And of course that sparked a lot of conspiracy that yours truly seized upon. And then when I got to speak to the guy, I came out of the conversation with such a different opinion of him. And we'll come back now. I'll bring us back here.
Yep.
Welcome back, ladies and gentlemen. Brendan Drachler is here with me today. He's from the Rochester Institute of Technology. He is also a podcaster in his own right, a very good one at that. Brendan, tell people where they can get the state of the universe again. I'm determined to elevate you way to the top of the ranks, man.
Yeah, well, we're trying to get to number 1 in 2020. Astronomy, physics, Apple Podcasts, we're number 3. Let's get to number 1. TheStateOfTheUniverse.com, YouTube, wherever podcasts are found.
Number 3,
wherever they're
dude.
found.
Come on, number 3 is pretty good. You should be bigging yourself up. You should be
Well,
blowing your
We're
trumpet
not
loud.
we're not number 1, and then we got to shoot for, number 1 in science in general, and then we got to shoot for number 1 overall. We just got to keep climbing.
Joe Rogan is sitting quaking in his boots right now.
I don't think so.
We're coming for you, Joe. I'd love to see you on Joe Rogan one day. That would be a good show. But before the break, we were getting into the whole debate over science. And in recent years, for whatever reason, science and scientists have really been given or been cast in a bad light. Now, I take some responsibility for at times talking about science and looking at the very negative side of things. And I was sharing with you during the break how at one point I thought Geordie Rose was demonic and the devil himself personified for some of the things he was saying. However, after a chat with Geordie, which really, opened my eyes a lot, I came to realize that he's like you. He's just a really keen scientist, and his goal in life is to create things that don't exist, be it quantum computers, be it artificial general intelligence. That's what he's chasing. And again, it gave me a totally different view on him, and it made me rethink science, and it made me think about the ways that science in recent times, it really has been viewed upon in a different light by a large amount of people. And I still I can't wrap my head around what happened there. What caused people to kind of reject the science that for years we had relied upon and we had advanced our knowledge with. And then it seemed like just in the space of a couple of months, everything went a bit crazy. What do you say to that, man?
Here's the good thing, Kev. I never encounter these people. I never encounter anyone who is anti-science in any way. Thankfully, the people that come to my show are people who are attracted because they want to learn, and that's it. We were talking before the break about people who don't trust science or who think space is fake or think all these other weird things, and I always find that these people just don't understand science. They don't understand the field. They don't understand that. Okay, so for example, when I go into work each day, there's probably, I don't know, let's think, maybe 70 other astrophysicists that work at the same place as me. Okay? Now, that's one university. Okay? All of us, all 70 of us, we work on different things. We use different data sets. We work with different telescopes. We do all of that. And every single one of us works with data that those telescopes collected. Okay? It could be whatever data you want. It doesn't matter what data it is. The point is it comes from a different place. So do people think that either we are in on the joke and we just go and sit in an office all day and don't actually do anything? Or do they think that the data that is given to us is fake? And then if the data that's given to us is fake and we are actually just trying to solve problems, but the government is secretly colluding and the data we have is no good, then you have to contend with the fact, Kev, that, well, there's 70 of us working on probably each 3 different telescopes apiece. So, you're talking about hundreds of telescopes. Then different universities use different telescopes. So now you're talking about many, 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 many places, many people using data. Is the data fake? Does the government sit there and make up the data somewhere and then send it to us? But not all the telescopes are given by the government. So is the data real and just the stars up there are fake? I don't understand. We built LIGO. Is LIGO fake? Is the detection fake? Are the 1,000 people working there all in collusion to trick you? What are they tricking you for? Why are they tricking you about detecting gravitational waves? Why do you care if they detected gravitational waves? How does that help any government or any person? What are they doing? Funneling money through it? What is inside of those LIGO tubes? Just nothing. And they just used it to funnel $10 billion? Because the Pentagon's been pretty good at funneling billions of dollars without science for a pretty long time. I mean, they can just make it disappear. They could just never tell you about it. If they really wanted to, I see, this is the point, Kev. The point is it's so circular because no one can actually tell you why anyone faked space. No one can tell you.
Exactly. The key Bono question: who benefits here? Why? What's the
No
big
one
thing?
can tell you why there's 100,000 scientists across the world and all of us are tricking everyone somehow. Or we're being tricked. Maybe we're being tricked. Maybe all the data we work with, the tens of thousands of terabytes of data was created by someone sitting in the Pentagon. Yeah, that's probably it. Probably someone sat down and created random numbers that had to have meaning. So they charted millions of stars all over the sky and they said, we're going to give this star this parameter and we're going to give this star this parameter and then we're going to put it all in one big database and the astrophysicists are all going to be fooled. It's so stupid.
Yeah, again, I mean, you don't have to convert me. You know me. I'm a science head. I just sometimes, when I end up in that conversation, which does happen sometimes I'll totally avoid it just so I don't get involved in it, because it usually ends up in a conversation that turns into maybe an argument that goes nowhere, and nobody's better off at the end of it, because the person who you're interacting with will still walk away with that same idea. I was just hoping you could give me some pointers as to some really good kind of comebacks. And one of our regular callers, I really love Naysay, he comes on the show, and there's not just Naysay, but a lot of people think maybe the Earth is tilted somewhat, or the moon may have moved. What would you say to that? Because again, I would counter that with amateur astronomers. Surely they would notice something, because maybe the night sky would change if we've slightly shifted or something, or if the moon shifted. Again, I don't have the knowledge or the kind of way to debunk it, so to speak, or to counter it. So how would you answer Naysay's question of, or his idea that we may have moved the planet or the moon?
Like it moved recently?
Well, the last few years, I would say. Maybe, I think Naysay's been talking about this a couple of years now. And to give you some background, Naysay's a long-time listener, good friend, and he comes from Native American stock. And he talks about how the Native Americans, how they've noticed changes in... And I remember a story years ago. It was a couple of years ago, about how the Inuits had said that they were expecting the sun to return on a certain day, but then the daylight didn't come back for maybe a couple of days afterwards. I can't remember quite off the top of my head. It was quite a famous video at the time. Conspiracy theorists like me, we seized upon it. But how would you counter that, or how would you address that if Naysay, Kev, our good friend, was to phone into your show?
Well, I would have to know his like data. Is his data that Native American tribes said it would happen? That's not very good data.
I'm not sure. I mean, and again, Naysay's a very, very good supporter and friend of the show, and that's why I was hoping maybe you could have some information to either counter it or point them in the right direction, somewhere to look at, maybe.
Well, I would just say if the Earth suddenly tilted an appreciable amount, you would be able to tell. Amateur astronomers would be able to tell.
You see, my amateur astronomers
would be able to tell.
Because I usually use the amateur astronomers thing, and I mentioned this the other night when Naysay was on, and they've got nothing. They've got no dog in this fight. You know, if they're just an amateur astronomer, I mean, they don't have funding to worry about or anything like that. So I would imagine that out of the what must be millions of amateur astronomers out there, someone would notice, right?
Yeah. I don't quite know the context. Like,
No,
does he think it happened?
That's my bad, because really I'm trying to parrot secondhand what's been said to me. So I take responsibility for that. And I know Naysay's listening right now, and I was just hoping. I've made up a new word there. I was hoping maybe we could get some information to him that might clear it up. But that's okay. That's okay, and I'm
Well,
sure.
shout out to him.
Yep.
Thanks for listening to Kev's show.
And
Sorry, I
no,
don't
and I'm
quite know
sure
your.
Nacy, I'll have the phones open tomorrow. He can phone me up tomorrow, and we can have a chat about it as well. But before
Yeah,
you go
and
away,
feel free to shoot me an email. Tell me what
yeah,
you think, and we can have a conversation.
absolutely, because folks, any of you out there, Brendan is very accessible. It was very easy to get Brendan onto the show the first time, no problems at all. He's one of these people you can approach, and I would imagine he will give you the information that may or may not answer your questions. I can't promise you it'll answer everything that you're looking for. However, I confidently recommend you contact Brendan because, in my opinion, he definitely is somebody that's more qualified than me to speak to a lot of these things. Now, before we go away today, let's come back down to terra firma and something that I've been covering recently on the show and something that has really shocked people around the world. And that is, of course, these horrendous fires over in Australia. We've spoke about the climate change debate before, Brendan, and a lot of the mainstream media and a lot of the people who are proponents of the global warming stroke climate change kind of cult, as I call them right now, they are absolutely beside themselves because it's almost as if, look, we told you global warming, these things would happen. And I was reading today how if our warming continues, we can expect the Australian bushfires to become a very regular occurrence, not only in Australia, but other parts of the world as well. And we've lost over 1 billion wildlife. Australians have lost their lives. What says Brendan to what's going on over in Australia right now?
First off, that billion wildlife figure, I'm not convinced I buy that because
no, you know, I don't know
okay,
how you work. I don't know how you figure that one out as well. I must admit.
here's how they did it. Okay, I looked this up the other day because I was like, when you hear that number as a scientist, I'm not a biologist. I'm not like someone who deals with animals. I don't know about wildlife. I don't know about habitat. I don't know anything about that. But to me, I hear 1 billion and I think that's a lot of animals. Is that right? Is that number correct? The first thing you should always think when you hear something is, does that sound logical? To me, it didn't sound logical. So there's a scientist who came up with the number. And the way he came up with the number is he looked at the density of wildlife in Australia, which has been something that's been mapped for almost every place in the world. Like how many animals are there per, I don't know, hectare or whatever. What's the wildlife population like? And then you take that number and you take the average number of animals per acre, let's say, and then you figure out how many acres burnt down, and therefore you lost that many animals. That's not, for me, you're assuming that the animals are standing still, right? I mean, you're assuming that the average number of animals in any one given area is not going to be able to get away from the fire. I don't understand. That's weird to me. Do rabbits just burn to death? I don't know if rabbits just burn to death. Like I said, I'm not an animal guy. So does a rabbit just stand there and get caught on fire? I don't understand. You know? And the other thing is, this is very important. And, you know, here we get fake news media again. He was very particular when he published that number to say affected, not killed. Never said killed, affected. And they're very different words. Affected and killed are different words. They're very different words. In this context, they are literally polar opposites. Affected and killed are different. So all of these media outlets reporting 1 billion animals killed, it's bullshit. Is there a lot of animals affected? Is it sad? Does it suck? Yes. But we can't continue to like peddle these anti-science bullshit claims everywhere and then expect people to believe science. You know, there's a reason people don't believe science. It's because continually you have, and I'm not saying that it's the scientist's fault. He did everything he was supposed to do. He did research. He published what he found. He published his means of getting to that number, and he purposely used the term affected. Okay, great. But then you turn around and you have media sensationalizing this number, and it's bothersome. It's annoying.
It's a lot of animals. I know that. It does break my heart. It really does. I'm an animal guy. Again,
me too, man.
Sometimes I wonder, you know, us humans, we do care more about animals than we do each other at times.
Oh, I know. Yeah, I know a couple of vegans who would gladly murder all the humans.
Yep, exactly. Now, the fires themselves. Global warming, Brendan?
Yeah, the fires suck.
Mm-hmm.
Okay, it's a shame, but it's so weird because this isn't the worst fire in the history of Australia. So number one, they were set by humans. A lot of them were set by humans, which is shitty. Okay, and what do you do with those humans? I don't know. Do you kill them? I'm not sure. I don't know what you do. Capital punishment, hang them in this town square. I don't know what you do. All right, but that's definitely, you need some punishment for that one. Um, yeah. So climate change. What role does it play in these fires? Well, we know that there is something that contributes to the fires in Australia, known as the Indian Ocean Dipole. Do you know what this is? Have you ever heard
No,
of
I've
this,
never
Kev?
heard of that one. No.
Okay, so there's this concept, which has been known since the 60s, and it's not necessarily a climate change idea. It's just a climate of that region. What tends to happen is in the Indian Ocean, there can be a positive dipole and a negative dipole. If the water is warmer in the West Indian Ocean and colder in the East, then you get a positive dipole. A positive Indian Ocean dipole means that you get less rain and you get drought conditions in Australia. Okay? A negative dipole means the opposite. It means increased rainfall. Okay?
Yep.
Now, this has been known for a long time, and this has been affecting Australia for a long time. And this is not the worst bushfire in the history of Australia. The 70s was incredibly bad. The 90s was bad. There's been decades that have been incredibly bad for fires in Australia. Now, there is some literature that says that climate change will make, and will is important, will make the Indian Ocean dipole happen more frequently. So it'll flip stages more frequently, which means drought years will occur much more commonly in Australia. That is the only literature that you can find that ties climate change to what's happening right now. What's happening right now in Australia, I don't understand how people are saying it's, a product of climate change. I don't understand that. It's one of those weird things where.
You know why I think they're doing that, Brendan, just quickly?
What?
I think
Yep.
because with Greta and with everything that's going on with the climate change cult right now, I think the timing of this fire, it really it was advantageous to people pushing the climate change agenda, shall we say. So
Of course.
I think with people in their current state of mind, with all of the propaganda and all of the information coming at us because of Greta and the UN and everything else, I think that almost accentuates the fire going on right now, and they've seized upon that to use it as an example to scare people of what's coming.
Does Greta make you mad? She makes me so
She
mad.
makes
I don't even
me
know
angry.
why.
I know a child should not make me angry, and in some
that
ways,
high school dropout makes me so mad. I
in
just
some
want,
ways, I think she herself is a victim because she's been used by older people to push something that I don't really think she truly understands herself.
And the thing is, like, okay, with the broad strokes of her argument, I'm on her side. Like broad stroke. I don't think that you should stop using fossil fuels tomorrow. I don't think the planet is going to explode if you don't. I think that you have to be smart, you have to be economical, you have to, take steps to phase them out. That's where we stop agreeing. She's like a militant I don't even know if you call it environmentalist, because the drastic changes that would happen across the world from phasing fossil fuels out overnight could potentially result in an environment that is way worse, because you would have literal economies collapsing.
I would probably call her an eco-terrorist.
Yes, it's like, okay. And the thing is, look at how poor countries pollute. That's another thing. Like, do you really want to take away such an incredible commodity for so many countries? Because poorer countries tend to pollute way worse than richer countries, when they're emerging, when they're becoming technologically sufficient and advanced. Look at India, right? Look at China. China is finally through its emergence, and it is relying almost entirely on coal. You look at India. India is beginning to become technologically advanced and emerge as a world power, and they are now relying heavily on coal and becoming incredibly polluted. So it's a weird. It's not a simple answer. That's the thing. Like, Greta, I know she wants to believe in her 16-year-old high school dropout brain that the answer is simple, but it's just not.
And when we
And
look
like,
at
I feel
Australia,
bad for her, man. I
so do
feel
I.
bad that she's in this
I think,
situation,
yeah, I think she's been used, Brendan.
but
I
she
really do.
pisses me off
I
so bad.
know. At the same time, yes, exactly. How dare you? How dare you,
Like,
Brendan?
the thing is, I think it's like I kind of think it's bad for science, because it's the same thing where like I see these okay.
Well, hang on then, because I have got an article here from the Telegraph. Now, the Telegraph is one of our more respected mainstream publications over here, okay?
Uh-huh.
And the headline reads, and I'll show the audience here as well, and I nearly fell off my chair when I read this coming from the mainstream. The UN's woke climate change propaganda is an insult to science. And this comes from a lady called Cheryl Jacobs. And I believe she herself is a scientist. And she
Mm-hmm.
finds it very insulting to science itself, some of the stuff that's been spouted in the name of climate change. So yeah, it's a very interesting article. I'll send that to the TFR chat room for people to read. But yeah, it goes into a lot of stuff there. A lot of stuff we talk about as well, Brendan. We're not the only people that are saying, like you said there, you know, it's basically an insult to science, you know?
Yeah, that's the thing. It's like, okay, people think that if they can spread science propaganda or fake science in the name of good, like, because they think, okay, I think that people like Greta, and I think that people who want to phase out fossil fuels tomorrow, I think that they want to do good. I don't think that they're evil. I don't think that they want the world's economies to collapse. I think that they honestly think this is the solution, right? But just because you think it's the right answer doesn't mean that you can publish all the science in the world or talk about all the science in the world and somehow skew it to your beliefs. That's not how science works. Okay, it's just not. Is there a problem? Yeah. Do we need to solve a problem? Sure. Do we need to solve it by tomorrow? No. Is the whole world going to die tomorrow if we don't solve it? No. It's just not. And that's probably what that article is saying.
Yeah, and when it comes to Australia as well, I mean, I was quite shocked when I was seeing information about how all of the water that usually comes down the creeks and the streams and the rivers, it's been held back behind a couple of dams. We've had the Australian government that have put legislation in place where the Aboriginals can't do the same kind of forest management that maybe they used to do in previous times, i.e. cutting fire breaks and just basic forest management. And
Mm-hmm.
with what you're saying with that dipole thing as well, it's almost the perfect storm, really, that's happened over there. Call it a
Yes.
firestorm,
Yeah.
call it what you may, but
Yeah. Now I
a
will
lot of
say
things
that,
have
like,
contributed to it, yeah.
some models indicate that, warming of the atmosphere can cause an increased frequency of the dipole. I think I mentioned this before. Most predictions put the dipole flipping every 17 years. Okay, so it tends to provide the worst droughts and the worst bushfires every 17 years. That's what the average tends to be. It makes sense that that's why you tend to see the worst fires every 2 decades. You tended to see the worst fires in the 70s, the 90s, and now you have them occurring a little late, but nevertheless in the 2020s. So 17 years tends to be the average. Some models indicate, and it's important to say that not all models are perfect. Actually, no model is perfect. All models are wrong. Some are useful. That's a saying that my professor used to always say to me when I was younger. All models are wrong. Some are useful. That's a useful thing to abide by. Because they are models. They don't take everything into account. They only consider, as many data points as they can consider. And so some indicate that the dipole will change from being every 17 years to being every 6 years or 8 years, or a shorter period of time. Again, it's not going to cause Australia to disappear. Is it going to cause wildlife and forests to be lost? Yes. Is that preventable? Yeah, there are steps to take. I mean, we just talked about it. Like, man, this didn't start because there's carbon in the atmosphere. These fires didn't start because there's carbon in the atmosphere. Let's not pretend they did. They started because of human negligence. And is that something that can be fixed? Yeah. Yeah, we can hopefully fix that in the future. But that's not going to be fixed tomorrow either. So we need to be intelligent about the climate movement. Now, I see a lot of politicians say the exact same thing, and they're bullshitting you, frankly, because we do need to make some changes over the next 50 years. We would ideally like to phase out the use of fossil fuels. If even if you don't believe in climate change, then you should at least know that you shouldn't breathe in the air coming out of an exhaust.
Yeah.
You know, so even if you're not on the climate change thing, you should at least understand that it's probably you know, if you run a hose from your exhaust into the cabin of your car, you're going to die in a few minutes. So why then do you think it's okay to pump millions of vehicles exhausts into the atmosphere? Because guess what? The atmosphere is closed. Okay? Even if you believe space is fake, the atmosphere is still closed.
We're in a dome. I'm only joking,
Yeah,
Brendan.
we're
We're
under the
not
dome,
living in a
man.
dome. Well,
We're
folks,
under
we're
the
out of
dome.
time. Brendan Drachler, check out the stateoftheuniverse.com for all the top science podcasts. I'll be back tomorrow. The phones will be open. Kev, Nacy, please phone me tomorrow. I'll be back same time, same place, wherever you are. Make it TFR and then touch that dial. Now, Brendan, we're still on YouTube for just a moment here until I thank the audience for tuning in, for hanging out with us today. I want to thank you as well, Brendan. You've given me a lot to think about, and I'll be going and diving off this cliff that you showed me, the Verona Rupes. I'll be taking a look at that when we get off the show here. Again, man, let me thank you. It's not the full audience, but the people here on YouTube. Thank you for bringing the information that you do bring to the show. I know I always find something that makes me learn something. I hope all the audience out there have learned something, or at least you've given them stuff to think about. And I thank you for your time, and I thank you for just being you, man. I love hanging out with you, dude. It's super cool.
Thanks for everything, Kev. Thanks for having me on. Thanks to the people listening. The people listening, like Kev was saying, I try to be as accessible as possible.
Yes.
There's contacts forms on my website. You could do it at YouTube comments. I don't care. I'll try to get back to you if you have honest questions. If you have actual things you're concerned about, if you think something I say is bullshit and you have some reason to suspect why it's bullshit, reach out. I'm happy to talk to you. Here's the thing, man. So much science denial is born out of the fact that, like, some scientists tend to put on this like era of I don't know, being better than everyone else. I don't try to do that.
I must admit though, between yourself, Brian Keating, Geordie Rose, I found the exact opposite.
Yeah.
In reality, people like yourself, you actually enjoy talking about these subjects. It's your life, it's your passion.
Mm-hmm.
And I've had a whole kind of epiphany when it came to mainstream science through talking to real scientists. You see, maybe my problem was because I was surrounded in an echo chamber with people who were questioning things, and none of us had that scientific answer to it.
There's a sect of science, that people that just, suit and tie white dudes, came from rich families, don't talk to anyone. Those, sure, be skeptical of those Muppets, but the majority of us, man, we're fucking normal people, and we're happy to talk to anyone.
Absolutely, brother. I love you to bits. Folks, I'll be back tomorrow, and I will play my usual little outro now. And I'll be back for the safe space tomorrow in the afternoon. And then tomorrow night, we'll open up the phones. I hope Nacy can call in. And I hope Nacy understands that I wasn't belittling his ideas. I wasn't rubbishing them. I was hoping to add some information that would maybe give him something to think about, or it might clear up some things, or maybe it didn't. But as long as Kev out there realizes that that was not some kind of personal picking on him, it was just a perfect example, because this came up in the conversation, I believe, last night and the last time Kev phoned. So a big shout out to Kev out there, a big shout out to all of you, and I'll be back tomorrow, folks. So let's take it out. Keep your mind open. Keep looking for the woo, but not to the point where your brain turns to black goo.